Welcome to this session still. We are still in carbohydrates as chemicals of life, and specifically we are looking at polysaccharides. We said there are very many polysaccharides. There is cellulose, there is starch, so we have so far discussed starch, and we lastly hinted on why starch is a better storage molecule than other carbohydrates. So let's change our focus and then look at another carbohydrate called cellulose, another polysaccharide called cellulose. So cellulose is a polysaccharide. We already know that. So is a polysaccharide. A polysaccharide consisting of, what are the building blocks of this polysaccharide? 1 beta glucose units. It consists of beta glucose units. We looked at how beta glucose units look like. Then secondly, it consists of 1,4-glycosidic bonds. 1,4-glycosidic bonds. Then cellulose is unique and very, very unique that it consists of cross bridges of hydrogen bonds linking up several cellulose polysaccharide chains. So within cellulose does not exist singly, but rather a collection of several polysaccharide units linked up together by hydrogen bonds. So if this is one chain, cellulose polysaccharide chain, another cellulose polysaccharide chain is also running parallel to it. Another one is running parallel to it. So this one will be a polysaccharide chain, a cellulose chain. That cellulose chain is linked to another one by hydrogen bonds that are very many. So those are what we are calling cross bridges. We have called them hydrogen bonds. So when we are looking at water, we specifically said that hydrogen bonds are bonds between hydrogen and a more electronegative element that is not directly bonded to oxygen. We said the bond between oxygen that is not directly bonded to hydrogen But we said the bond between hydrogen and the more electronegative element, an electrostatic bond, because it is attracting a partial negative charge and a partial positive charge. So these cross linkages, how do they arise? Let's also focus on that. How do they arise? How do they arise in the molecule? So the polysaccharide chains are in this format. Let me draw the polysaccharide chains. Now I'm going to use the cyclic way of representing this. The other way of representing our cyclic forms, I said whenever there is a corner, there is a carbon atom. So allow me to draw it like that, and I put this CH2 there and OH there. Then, if it is one phosphoglycosidic bond, it is here, oxygen, like that. Use another color so that we can illustrate better how the glucose units are arranged inside the polysaccharide chain. So this carbon atom number 4, this is carbon atom number 1. So I want to remove it and use the cyclic way. So this time, this is inverted, such that our CH2OH is facing downwards. So meaning, this was carbon atom number 1, number 2, number 3, number 4, number 5, number 6. The other side, this was our carbon atom number 1, 2, 3, 4, 5, and 6. So our 1,4 glycosidic bond is there. But the glucose molecules within cellulose are interchanged that way, that one faces upwards, another one faces downwards. How do the third one look like? Let me use another color to indicate how will the third one look like. There is a glycosidic bond there, carbon atom number 4. Like that. That would be carbon atom number. Then carbon atom number 6 would be a CH2OH. So this would be carbon atom number 4, 3, 2, carbon atom number 1, number 5, carbon atom number 6. So we have one for glycosidic bond, one for glycosidic bond. That's what it consists of. So you can see this zigzag arrangement of the glucose molecules. They keep alternating. Carbon atom number 6 upwards, carbon atom number 6 downwards. Now, if we have another polysaccharide chain below, let's begin with the black here. If now we have another polysaccharide chain below, and this time the beginning is inverted. We have so it would mean CH2 OH is here. Then another polysaccharide chain. Allow me to do some editing here so that we have this. If this one was inverted, how would the bond look like? The bond would be also up there. Then this bond here would remain there. Okay. So here we have our bond here. Then another glucose molecule here. So our CH2 OH would be here. Another glucose molecule